Hi, a warm welcome to the another session of our engineering chemistry. That is one of the topic what we are discussing. That is a polymeric chemistry or polymer chemistry. Last class we are explained already. We are seen some of the introduction part of the polymers and the classification of polymer, and again the types of polymers, the types of polymerization we are seeing. These topics we are covered in our last session. These are the last topics up to this condensation polymers, and we are seen. After that, we have the difference between the addition polymerization and condensation polymerization. Already I told you addition polymerization also called as a chain polymerization, condensation polymerization also called as a step growth polymerization. And again in this, in addition polymerization, we are not getting any byproduct. There is no formation of the byproducts, and in the condensation polymerizations we are getting byproducts like water and HCl. It is a main difference between the addition and condensation polymerization. After that, we have the another one topic, that is nothing but the plastics. The plastics also called as a resins. The plastics also called as a resins. These plastics are organic substances. These plastics are organic substances. They have the plasticity. They possesses the plasticity characters. They possesses the plasticity character. These are we called as a plastics. The term plastics must be differentiated from resins. And resins are basics binding material which from a major part of the plastic. For example, we will see some of the examples for the plastics. Again, the plastics are classified into two types. One is thermoplastics and another one is thermosetting plastics. The plastics are classified into two types. One is thermoplastic, another one is thermosetting plastics. Now we will see the characters of the thermoplastics and thermosetting plastics and the difference between the thermoplastics and thermosetting plastics. What is mean by the thermoplastic? Thermoplastics, when they become soft on heating and hard on cooling. If we take a plastic, that plastic is soft on heating. When we are heated that plastic, it will be module, and when it is a cool down, it will be rigid. It will not change its shape. But coming to the thermosetting plastics, they become soft initial heating and hard on cooling. On reheating, they become not hard. Means they are thermoplastics, they are changing their shape. When we are heating, they changing their shape, then they are cooling and they are hard. When we are heating again they will change their shape. But thermosetting plastics are not like that. When we are heating, they will change their shape, and when they are cooled down, they are rigid, and when we are heating again, they will not change their shape. It is a main difference between the thermoplastics and thermosetting plastics. And thermoplastics are made by the addition polymerization. Thermoplastics are involving in addition polymerization, and thermosetting plastics are involving in condensation polymerization. Thermoplastics are soft. They have weak bonding. Thermoplastics are soft. They have weak bonding, and the thermosetting plastics, they have tightly and strong covalent bonds they have. And another one, they have either linear or branched structure. Thermoplastics have the linear or the branched structure. In here, the thermosetting plastic polymers, they have the 3D in structures. And another one part, the chemical structure is not altered during the heating and cooling. Means they are not changing their chemical formula or the nature of the chemical, but when we are heating, they are modeling, they are changing their places of the bonds. And another one, they are low in molecular weight. Thermoplastics are low in molecular weight when compared to the thermosetting plastics. Thermosetting plastics are strong bonds and cross-linked, and they are not soluble in almost organic solvents. These are thermoplastics are easily solving in organic solvents. For example, best example is polyethylene and polypropylene and PVC. Polyvinyl chloride, these are some of the best example for the thermoplastics, and bakelite and polyester resins, these are some of the thiocol, these are some of the examples for a thermosetting plastics. These are some of the characters or difference between the thermoplastics and thermosetting plastics. And what is the simple definition for the plastics? Plastics, they have the plasticity, they possesses the plasticity character. And it is also another one, the fiber reinforced plastic. If plastic are brittle, they have weak bonds. To strengthen that plastic, to strengthen that plastic matrix, we are mixing that matrix with some of the high strength fibers. This process we called as a fiber reinforced plastics. When we are reinforced this fiber with that plastic matrix, they are strengthened in, and they are increasing their strength, and they are corrosion resistance. These are some of the applications, like the FRPs. When we are mixing with polymer matrix, they are strengthening their strength, so they are using in making of boat nut and acid storage and motor cars, and these are some of the examples of the fiber reinforced plastic. And this is one of the important topic after the plastics. It is nothing but the elastomers. The elastomers naturally we called as a rubbers, but the rubbers and the elastomers, they have the slight difference. When the scientists, they are aimed to prepare the rubbers, but they get rubber type of materials. They want to get the rubbers, but rubber type, almost 100% rubber type materials, they are synthesized. The rubber type material we called elastomers. These elastomers have the elasticity property. These elastomers have the elasticity property. Due to that elasticity property, they have the bending and they wagging. They are polymer to strengthen response to microscopic stress, and they have the property of elasticity. They have elastomers. And how the elastomers are preparing? Naturally, the milk type solution we called latex. The milk type precipitation or solution, that is nothing but the latex. The latex we are getting from the tree we called Hevea brasiliensis. These trees, they are giving milk type, the precipitate or the solution, that is nothing but the latex. Due to that latex, we are preparing these natural rubbers as well as some of the synthetic rubbers. But when we are talking about the rubbers or elastomers, they have weakened their strength. They obey up to some degree centigrades only. After, they are brittle in their character. To strengthen that rubber or elastomers, we are choosing one method we called as a vulcanization. This vulcanization process helps us to increase the strength of the elastomers or the polymer. In this case, what we are doing, the rubber or the elastomers, they are treating with sulfur. when the rubber or elastomers are treating the sulfur at the high temperature, and this rubber mixing with sulfur, this process we called as a vulcanization process. This process we called as a vulcanization process. When the sulfur is mixed with rubber or elastomers, the sulfur are making some cross-linked bonds, to strengthen the elastomers. This is nothing but the vulcanization. Due to the vulcanization, what are the advantage for us? Some of the advantage we have here. Vulcanized rubber has good tensile strength and load bearing capacity. It will increasing his capacity. And vulcanization rubber has good elasticity depending on the extent of the vulcanization. And another one, vulcanized rubber have the high resistance to the oxidation. It have the high resistance to the oxidation. These are some of the advantages we have with the vulcanization process. And to understand this vulcanization, for example, the rubber nothing but the polyisoprene. The polyisoprene we called as our natural rubber. The natural rubber we called as a polyisoprene. The isoprene involving in polymerization reaction, we are getting the polyisoprene. This is a structure of the polyisoprene. The polyisoprene, when it is mixed with sulfur, they are forming some cross-linked bond between the one isoprene to another isoprene. When they are mixed with sulfur, due to the sulfur cross-linked, the vulcanized rubber was synthesizing, and we are getting some advantage due to this method. And after some of the examples for the elastomers, these are some of the synthetic rubbers. The synthetic rubber, first one of the best example is Buna S. The Buna S also called as a styrene rubber. Buna S also called as a styrene rubber. The Buna S also called as a government styrene rubber. Government styrene rubber. Buna S also called as a government styrene rubber. And we will see about the preparation of the Buna S. Before seeing, we will see what is mean by the Buna S. The name itself giving answer to us. Here the Bu and that is Na, Buna 1 and S. We have the three chemical combination, we are getting the Buna S. That is nothing but the Bu means butadiene. Bu means butadiene, and Na means it is nothing but the sodium, and S means nothing but the styrene. Sodium nothing but the styrene. When two monomers, one is butadiene and another one is styrene, these two monomers when are undergoing in polymerization in the presence of sodium catalyst. Here you can write in the presence of sodium catalyst, we are getting the Buna S. We are getting the Buna S. It is the Buna S preparation. Means Buna S we are synthesizing by the combination of butadiene and styrene in the presence of sodium. We call Buna S. Buna S is one of the synthetic rubber. The Buna S also called as a government styrene rubber. And what are the characters and applications of the Buna S? Some of the characters and applications of Buna S we have here. We will see now some of the properties. It has high abrasion and resistance and high load bearing capacity, like that vulcanized rubber, and easily oxidized in the presence of ozone, and its vulcanization process is similar to the natural rubber, like what we are done for the natural rubber. Here also we are doing the same. And what are the some of the application? To mainly manufacturing the tires. Mainly manufacturing the tires and wires and cable insulators. These are some of the applications we have with the Buna S. And it is another one of the example, that is thiacol rubber. Thiacol rubber. The thiacol rubber, we will see the preparation of the thiacol rubber, how we are preparing, how we are synthesizing the thiacol rubber. For the thiacol rubber, what we are doing the sodium and sulfur powder. We are mixing the sodium, sulfur, and it is again treated with the dichloroethane or ethylene dichloride. Thiacol rubber can be prepared by the condensation of 1,2 dichloroethane with sodium polysulfide. It is a sodium polysulfide. The sodium polysulfide, when it is reacting with 1,2 dichloroethane or ethylene dichloride, we are getting the thiacol. The thiacol also called as a polysulfide rubber. Thiacol also called as a polysulfide rubber. It is very simple for us, and these are some of the properties like what we are seen in Buna S. There are some of the gaskets to prepare the gaskets, and some of the rockets to prepare the rockets, and some of the properties like they have outstanding resistance to the sunlight. Like that, some of the properties and applications we have with thiacol rubber. After that, we have the next one topic, that is nothing but the conducting polymers. According to our knowledge, the polymers, they have act as a good insulator. They won't allow the electron flow with them. We call as a insulator. So plastics are good insulators. But what we are saying here, conducting polymers, means some of the polymers, they can allow the electron flow, means conductivity with them. This kind of the polymers we called as conducting polymer. What is a simple definition for the conducting polymers? And which polymers they are allow to electron flow with them? We called this kind of the polymers we called conducting polymers. These conducting polymers, due to maybe addition of some of the additives. When some of the additives are introduced in that polymer, they are changing their properties. The additive like some of the coppers and silver, some of the doping elements also. With addition some of the doping elements also, we are the plastics converting into the polymers converting into conducting polymer. Mainly the conductivity of the polymer due to the delocalization of pi bonds. Due to these delocalization of pi bonds, the electrons are moving from higher energy to lower energy. For example, valency bond to conduction band. These delocalized electrons are helps to jump from basic level to higher level. These are, we will see, these are some of the examples for the conducting polymers. And these conducting polymers are two types: intrinsic conducting polymer and extrinsic conducting polymers. Conducting polymers are two types: intrinsic conducting polymers and extrinsic conducting polymer. These intrinsic conducting polymers, may be due to the additives like pi electrons, means with the conjugation they are exhibiting the conductivity, and conductivity due to the plus and negative charge. These two are comes under the intrinsic conducting polymer. When coming to the second type, that is eccentric conducting polymer. This eccentric conducting polymer is due to the filled with conducting element. When we are adding to the conducting elements and blending with blends with the help of blending. Here the conducting the elements and the blending. Due to these two types, we are getting second type of the conducting polymer, that is nothing but the eccentric conducting polymers. Now we will see about the intrinsic conducting polymer. Already we told you intrinsic conducting polymer is happens due to the conductivity of due to the pi delocalization electrons. When the pi delocalized electrons are present in that polymer, they are the responsible for the electricity. These polymers are characterized by the intrinsic conjugation of double bonds. Intrinsic conjugation of double bonds in their structure. These polymers having conjugated double bonds in the backbone possesses their conductivity due to the pi electrons delocalization. It is important. The electrical conductivity takes place only after thermal or photolytic activity of the electrons, which give them sufficient energy, to jump the gap to reach the conduction band. Already I told you, from electron to jump the valence band to conduction band, to jump the electron. For this they want some energy to jump the basic level to high level. For this, these pi electrons are helps. Due to these electrons moving, the electricity is possible in this kind of polymers we called as a conducting polymer. The one of the best example is trans polyacetylene. The trans polyacetylene is one of the best example for the conducting polymer. These are some of the applications of conducting polymer. Conducting polymers used in rechargeable batteries. Conducting polymers used in rechargeable batteries. These also can be used in photovoltaic devices. These also used in photovoltaic devices and can be used. They are in small size. They are small size, but they are producing the high current up to the 50 amperes. These are some of the applications of the conducting polymers. And another one topic we have in this, that is nothing but the biodegradable polymers. Again, according to our knowledge, the polymers are not degradable in the earth crust up to some hundreds of years. Up to some hundreds of years, these polymers they won't degradable on the earth crust. For that, what we are doing, we are preparing a biodegradable polymers. Biodegradable polymers. The biodegradable polymers, the simple definition for the biodegradable polymers, the which polymers are degradable in the earth crust by the enzymatic action of bacteria. By the enzymatic action of bacteria, these kind of polymers, they are easily degradable. These kind of the degradable polymers we called as a biodegradable polymers. Bio means the bacteria. These called biodegradable polymer. Those polymers which are degradable by the enzymatic action of nature occurring microorganisms and bacteria called biodegradable polymers. The sum of the PLA, polylactic acid, and PVA, polyvinyl alcohol, and bipolars, these are some of the best example for the biodegradable polymers. These are some of the best example for the biodegradable polymer. Now we will take one example, the PVA, polyvinyl alcohol. The polyvinyl alcohol, it is undergoing in addition polymerization. In this addition polymerization, the polyvinyl alcohol is easily dissolving. It easily dissolving in water soluble. It is easily dissolving in water. Due to that, we call as a water soluble synthetic polymer. The polyvinyl alcohol is easily dissolving in water. Due to that reason, this polyvinyl alcohol we call as a water soluble synthetic polymer. It has a hydrolyzed formula like CS2 CHOH, and it is used in paper making, textile wrap staging. These are some of the, and they have the also using in variety of coating and 3D printings. These are some of the, and the preparation, the vinyl alcohol. It is a vinyl alcohol. The vinyl alcohol is undergoing in addition polymerization. In undergoing addition polymerization, we are getting poly. Poly means n number of. We are getting polyvinyl alcohol. It is a simple reaction we have, and these are the some of the important application of the PVA, polyvinyl alcohol. Especially the biodegradable polymers helps in medicinal industry. In medicinal industry, like in PVA used in drug delivery system, and PVA also used in wound dressing and wound healing, and it is a non-toxic. PVA is a non-toxic, and PVA used in fabrication and also coating, and especially for food industry they are using for food packing material. Polyvinyl alcohol, the biodegradable polymer, they are using for the some of the food packing material. These are some of the important applications we have with the biodegradable polymer. So this is a last slide. These are some of the important reference books, textbooks for this topic related queries. If you have any queries, kindly you can go through this kind of reference books. These reference books, they will help you for more clarity on these topics if you have any queries regarding these topics. And thank you.